All right, let's do this next problem. In this problem, we're going to use rectangles in order to approximate the area from this curve underneath 0 to 1400. So just to give you a little diagram of what we're going to be doing. Now, by the way, this curve is probably not going to look anything like this curve. I'm just going to try to do my best to visually show you what we're doing. So this curve is probably going to look, I don't know, something like this. And what we want to do is estimate the area of this section right here, and this point is 0, and this point is 1400. What we're going to do is use a couple rectangles to approximate it. In section 4.3, we're going to use an integral to find the exact answer. Now, unfortunately, we don't have time to show you the proof of it. It's a little bit complicated, but it uses a Riemann sum and a limit to take the number of rectangles to infinity, and it's one of my favorite proofs, but we'll gloss over it for now. Anyway, see how it says we're using 5 subintervals from 0 to 1400, and we're going to be using the left endpoint. Here's what that means. We're going to have 5 rectangles, and so what we want to do is just do 1400 divided by 5 in our calculator. So that means that we're going to be going by multiples of 280. So here's 280, here's 560, and I'm not going to put them all down here. I'll put one more down here, but 560 plus 280 is 840, and there will be a couple more in there. So there would be 280, 560, 840, add 280 again, will be 1120, and then watch, if you add 280 one more time, you get 1400. So those are going to be our rectangle points for doing this. Now, you'll notice that the first rectangle point has 0. So you notice that we have 5 rectangles and 6 endpoints. Okay? 5 rectangles and 6 endpoints. 0, 280, 560, 840, 1120, and then 1400. So we only want to use 5 rectangles, but we have 6 endpoints. So which of these 5 do we use? That's where this left or right endpoint comes in. If it's the left endpoints, we're going to use the 5 left ends. If it was the right endpoints, we would use these 5 and use the right ends of the rectangles. Either way, you only get 5 rectangles. One neat thing about this is that if you use one, it will be an underestimate, and if you use the other, it will be an overestimate, which should sort of kind of make sense. These rectangles, depending on the concavity of the curve, will either be above or below the area of the curve. So don't overcomplicate this. We have 5 rectangles, and we have their endpoints, and we're just going to add up all of their areas. And there's a lot of fancy symbols and terminology we could use that I'm just going to gloss over completely, because all we're doing is finding the area of 5 rectangles, and that's all we're doing. Don't overcomplicate this. Here are the 5 endpoints we're going to use. And notice that the width of every rectangle is always going to be the same. It's going to be 280, which was the length of our integral divided by 5. Okay, so rectangle 1 is equal to our width, 280, times, and what you do is you just we need to find these heights, and here's where this process becomes a little bit annoying. What we have to do is plug in all of these endpoints, 0, 280, 560, into the function, in order to figure out what these heights are, so that we can do the rectangles. So this is where this gets a little bit tedious. Luckily, 0 is pretty simple. If I plug in 0, I get blank, blank, and 50. So this first rectangle is just 280 times 50. Hooray! That's rectangle number 1. All right, rectangle number 2 is also 280, because that's the width from 280 to 560, and I'm using my left endpoint. We just did 0. Now we're doing 280. I need to find this height by plugging 280 into the equation. So here's where I'm likely to make a mistake, unfortunately. Negative 0.00001 times 280 squared minus 0.02 times 280 plus 50. Okay, hopefully that's correct. 43.616 will be the area of, so 43.616 is this height right here, If I multiply that by 280, I'll get the area of this second rectangle. And we'll look at rectangle number 2. Now let's do rectangle number 3. So we've done 0 and 280. Now I'm just going to use the line I did in the previous one, and I'm going to replace 280 with 560. See how fun this is? So then third rectangle will be 280 times 35.664. And we have 2 more rectangles to go. So we just did 560. Now let's do it again for 840. We get 26.144. Last one, we just did 840. Now we'll do 1120. So 1120 and 1120. Okay. Now notice that that's the end of our 5 rectangles. We did not use the point 1400, and that again is because we did the left endpoints. If we did the right endpoints, we would have used the 1400 and we wouldn't have used the 0. Okay, and notice that those would be slightly different rectangles. What's cool is the more rectangles you do, the more accurate this gets. And so what we'll do now is just add up all of these areas. So 280. Let's do this. Let's store 280 into a variable x. All right, so if I type x, I get 280. So I'll do x times 50. And I'll get 14000. Now I'll do 280 times 43.616. Get 12212.48. 280 times 35.664. 9985.92. And again, these are the areas of these 3 rectangles. Now we'll do the next one. 280 times 26.144. 7320.32. 280 times, well, 280 times 15.056, 4215.68. There's all of our rectangles, and now we just add up all those happy little numbers. So 14,000 plus 12212.48 plus 9985.92 plus 7320.32 plus 4215.68, and we get an answer of 47,734.4. And drum roll, please. Oh my goodness, we did it correctly. I love it. Hang on, we're off by a factor of 100. I wonder why that is. Well, we got the right answer. I'm going to stop this video here. It looks like I'm a little bit off of my answer from what I should have had just by a little bit of a factor. So I'm going to pause the video here, and in the next video I'll see why that is. You see why I don't like this. This is a very difficult process. Lots of opportunity to make a mistake because lots of calculations we have to make. So I'm going to see if I can figure out where we went wrong a little bit, or if we have the right answer. And we'll do this in the next video. Luckily in section 4.3 we'll use integrals and we'll get past this, but this is definitely probably one of the most, if not the most tedious problem in the entire class. So I'll see you in the next video and we'll make sure that this is correct.